Hello children, once again welcome to our physics class. Hope you all are fine over there. In the previous sessions we have completed our whole portion and today let's discuss about the sample question paper. Okay, so today we will discuss the sample question paper 2021. So fourth question belongs to physics and this is the first question in physics. Why does the sun appear white at noon? So this question is already there in your textbook. The answer to this question is already there in your textbook. Whenever the sun appears at noon, it appears to be white. Why? Because during noon, the sun is overhead, just above our head. So the light rays has to travel a very small distance in order to reach our eyes. Hence, there will be less scattering. So if the scattering is very less, the object appears to be white. Hence, the sun appear white at noon since there is least scattering at noon. Okay, so that is the answer for the fourth question. Now, let's discuss the fifth question. Both a spherical mirror and a thin spherical lens have a focal length of minus 15 centimeter. What type of mirror and lens are this? You had already studied. The focal length of convex mirror is negative. Focal length of concave lens is also negative. And here the given focal length is a negative value. It is negative 15 centimeter. So the mirror will be a convex mirror and the lens will be a concave lens. Okay, so the type of mirror is convex and the type of lens is concave. Then let's discuss the sixth question. The image formed by a concave mirror is observed to be real, inverted and larger than the object. So where is the object placed? Here a concave mirror. So this is a concave mirror and this is the pole, this is center of curvature, this is focus. And when do we obtain real, inverted and larger image than the object? So when the object is between C and F, we will get a real, inverted and magnified image. Also, when the object is at focus, here we will get a real, inverted and magnified image, but in this case the image formed at infinity, so we cannot represent the image in our diagram. Hence it is better to write the previous position, that is when the object is between center of curvature and focus. So when the object is between center of curvature and focus, you know the image is formed beyond center of curvature, isn't it? So here if you consider two rays, let one ray be the parallel ray and it pass through focus, and let consider another ray which is passing through focus, and this ray after reflection goes parallel to the principal axis and these two rays meet here. So you will get image here. See, it is a real, inverted and magnified image. Okay, so you can represent the position of the object like this when the object is between center of curvature and focus. So here object is placed between center of curvature and focus. Now what is the next question? It's an OR question. So let's discuss about that OR question. Name the part of the lens through which a ray of light passes without suffering any deviation. So if you consider any lens, let it be a convex lens or let it be a concave lens. Okay, so for a convex lens, this part is called the optical center, and whenever a light ray passes through an optical center, it will pass without any deviation. So if it is a concave lens, in that case also, this is optical center, and whenever light passes through this optical center, it goes without any deviation. So which is that point through which a ray of light passes without suffering any deviation? That is O. That is the center of the lens, which is called optical center. So optical center is the part of that lens. Now, let's discuss the seventh question. So, what is seventh question? In the arrangement shown in the figure, there are two coils wound on a non-conducting cylindrical rod. Initially, the key is not inserted in the circuit. That means no current flows through the coil 1 since no key is inserted. Later, the key is inserted and then removed shortly after. So, what are the two observations that can be noted from the galvanometer reading? You had already studied about this experiment. This is Faraday's third experiment in order to prove the concept of electromagnetic induction. And here initially the key is not inserted. Later when the key is inserted, what happens? When the key is inserted in coil 1, a momentary current flows through coil 2, which is indicated by the momentary deflection of galvanometer. So after deflection, the galvanometer needle goes back to the initial position. Further deflection cannot be observed. So when the key is inserted, at that moment a momentary deflection is observed in the galvanometer, which indicates the presence of momentary current in the coil 2. And similarly, when the key is removed from the coil 1, then also a momentary deflection is observed in the galvanometer, which indicates a momentary current, but this time the galvanometer needle deflects in the opposite direction. So whenever the key is inserted, a momentary deflection is observed. When the key is removed, then also a momentary deflection is observed, but in the reverse direction, in the opposite direction. So these are the two observations that can be noted from the galvanometer reading. Now, what is the next question? Draw the magnetic field lines around a straight current carrying conductor. So what is the magnetic field line? So if it is a current carrying conductor, suppose current is flowing in the upward direction, then the magnetic field around this current carrying conductor will be in the form of a concentric circles. And whenever you draw this concentric circles, you must be very careful. Initially, that means near the conductor, the concentric circles will be closely spaced, and finally the lines will be far apart like this. Okay. And this is the pattern. Also, we can easily find out the direction of this magnetic field lines applying the right hand rule that we will discuss towards the end of this session. Okay, similar question is there. So this is the pattern of the magnetic field lines around a straight current carrying conductor, and since current flows in the upward direction, whenever you apply the right hand rule, what will be the direction of the magnetic field line? It will be anti-clockwise. This will be the direction of magnetic field lines. Now, what is the ninth question? Next is the ninth question. Two unequal resistances are connected in parallel. If you are not provided with any other parameters, what can be said about the voltage drop across the two resistors? So if we consider two resistors like this, let this resistor be R1 and consider another resistor R2. Both are unequal resistors and both are connected in parallel. So let this be the parallel combination of these two resistors. And what can be said about the voltage drop across the two resistors? What is the voltage drop? You had already studied. In a parallel combination, the potential difference across each resistor will be the same. So whatever be the value of resistors, R1 and R2, even if they are unequal, the potential drop across each of these resistors will be same. Okay, so the potential drop will be equal. Then what is the R question? Some work is done to move a charge Q from infinity to a point A in space. The potential of the point A is given as V. What is the work done to move this charge from infinity in terms of Q and V? So you are supposed to find out the expression for work done in terms of charge Q and potential difference V. You had already studied an expression like this. Potential difference V is equal to W, that means work done divided by charge. potential difference V is equal to W by Q. So from this expression, you can easily arrive at the expression for work done. From this expression, what is work done? W. W is equal to potential difference into charge. So you can write work done is equal to Q into V. And this is the expression that you are supposed to write here. So the work done, W is equal to QV. So that's about the questions in this slide. Let's move on to the next slide. The next slide is a case study based questions. Read the following passage and answer any 4 questions from 19:1 to 19:5. So a case is given or a passage is given, and from the passage some questions are asked. Okay, so you are supposed to answer those questions. So let's read the passage. Sumadhi wanted to see the stars of the night sky. She knows that she needs a telescope to see those distant stars. She finds out that the telescopes which are made of lenses are called refracting telescopes, and the ones which are made of mirrors are called reflecting telescopes. So she decided to make a refracting telescope. She bought 2 lenses, L1 and L2, out of which L1 was bigger and L2 was smaller. The larger lens gathers and bends the light, while the smaller lens magnifies the image. Big, thick lenses are more powerful. So to see far away, she needed a big, powerful lens. Unfortunately, she realized that a big lens is very heavy. Heavy lenses are hard to make and difficult to hold in the right place. Also, since the light is passing through the lens, the surface of the lens has to be extremely smooth. Any flaws in the lens will change the image. It would be like looking through a dirty window. So based on the diagram shown, what kind of lenses would Sumadhi need to make the telescope? So here you can see the diagram, and on the diagram what type of lenses are used? Yeah, it is the convex lens. So option B is the correct answer, convex lenses. Now what is the second question? If the powers of the lenses L1 and L2 are in the ratio 4:1, what would be the ratio of the focal length of lenses of L1 and L2? So here the ratio of powers are given. So the ratio of powers, that means P1 by P2. P1 is the power of first lens, P2 is the power of second lens, and the ratio is 4:1. That means 4 by 1. And you already know power P is equal to 1 by F. So power P1 can be written as 1 by F1, where F1 is the focal length of the first lens, and P2 is 1 by F2, where F2 is the focal length of the second lens, that is equal to 4 by 1. Okay, now 1 by F1 plus 1 by F2 can be written as F2 by F1. So F2 by F1 is equal to 4 by 1. F2 by F1 is 4 by 1. Then what will be F1 by F2? F1 by F2 is equal to 1 by 4. So what is the ratio F1 is to F2? F1 is to F2 is equal to 1 is to 4. So what is the correct option? Option B, 1 is to 4. Okay. So option B is the correct answer, 1 is to 4. Now what is the third question? What is the formula for magnification obtained with a lens? Yeah, magnification formula is, you know, that ratio of height of image to the height of the object. Then what is the fourth question? Sumadhi needs some preliminary experiment with the lenses and found out that the magnification of the eyepiece is 3. So magnification produced M is equal to 3. If in her experiment with L2, she found an image at 24 centimeter. So image distance V is equal to 24 centimeter from the lenses. Magnification is 3 and image distance is 24 centimeter. What distance did she put the object? So you need to find out the object distance, that means U. So you had already learnt one relation for magnification, that is magnification m is equal to v by u. Therefore u is equal to v divided by m. What is v? V is 24 and what is m? M is 3. So 24 by 3 will be 8. So the object distance will be 8 centimeter. So which is the correct option? Correct option is option C. Okay, option C, that is 8 centimeter. So that's all about the questions in this slide. Let's move on to the next slide. So let's discuss the last question from the previous passage. Sumati bought not so thick lenses for the telescope and polished them. What advantages, if any, would she have with her choice of lenses? She will not have any advantage, as even thicker lenses would give clear images. It's not right. Then thicker lenses would have made the telescope easier to handle. It's wrong. Not so thick lenses would not make the telescope very heavy and also allow considerable amount of light to pass. It's the right option. Not so thick lenses will give her more magnification. It's wrong, because thick lenses will give more magnification. So C is the correct option. So in this case study based questions, you are supposed to attend only 4 out of 5 questions. So one question is optional. You need to attend only 4 questions out of 5. Now here also read the following and answer any 4 questions. So 5 questions will be there and you need to attend only any 4 questions. Here a solenoid is a long helical coil of wire through which a current is run in order to create a magnetic field. The magnetic field of the solenoid is the superposition of the fields due to the current through each coil. It is nearly uniform inside the solenoid and close to 0 outside, and is similar to the field of a bar magnet having a north pole at one end and a south pole at the other end, depending upon the direction of the current flow. The magnetic field produced in the solenoid is dependent on a few factors such as current in the coil, number of turns per unit length, etc. The following graph is obtained by a researcher while doing an experiment to see the variation of magnetic field with respect to the current in the solenoid. The unit of magnetic field as given in the graph attached is in millitesla and the current is given in ampere. So this is the graph. Okay, let's discuss the first question based on this passage. What type of energy conversion is observed in a linear solenoid? First one is mechanical to magnetic. Second is electrical to magnetic. Third option is electrical to mechanical. And the fourth option is magnetic to mechanical. So the correct option is electrical to mechanical. Option C is the correct option. That is the energy conversion occurring in a linear solenoid. Then, what is the second question? What will happen if a soft iron bar is placed inside the solenoid? What happens if a soft iron bar is placed inside the solenoid? The bar will be electrocuted, resulting in a short circuit. The bar will be magnetized as long as there is current in the circuit. The bar will be magnetized permanently. And the last option, sorry for the inconvenience, last option is not clearly observed. Okay, so anyways, the correct answer is B. The bar will be magnetized as long as there is current in the circuit. As long as current is flowing through the solenoid, the soft iron bar will be magnetized. Let's move on to the next slide. Now, what is the third question? The magnetic field produced inside the solenoid are similar to that of, yes, without any doubt we can say it is similar to that of bar magnet. So option A is the correct answer. Now, after analyzing the graph, a student writes the following statements. The magnetic field produced by the solenoid is inversely proportional to the current. That you already know, magnetic field produced by the solenoid is not inversely proportional to the current. The magnetic field produced by the solenoid is directly proportional to the current. It is the right one. The magnetic field produced by the solenoid is directly proportional to the square of the current. It's wrong. The magnetic field produced by the solenoid is independent of the current. It is also wrong. Magnetic field definitely depends upon the current and it will be directly proportional to the current. So option 2, only option 2 is the correct option. So from the following statements, you can choose the correct one. Only 4 is the wrong one. 1, 3 and 4 is the wrong one. 1 and 2 is the wrong one. And only 2. Only 2 is the correct option. So option D is the correct one. Now, what is the last question? From the graph, deduce which of the following statements is correct. For a current of 0.8 ampere, the magnetic field is 13 millitesla. So let's look at the graph. So 13 millitesla means somewhere here. Sorry, it will be somewhere here. And here the graph will be, graph will be 0.8. So it looks correct. For a magnetic field of 13 millitesla, the current is, for a current of 0.8 ampere, the magnetic field produced will be 13 millitesla. So first option is the correct option here. Okay. Now let's move on to the next slide.